Okay, good morning, guys. This is 10.4. Use inscribed angles and polygons. Like always, if you need the teacher to pause the video, go ahead and do so. And then you can get caught up with your notes. All right, guys. So before I even talk about an inscribed angle, let's talk about what we've known so far. The other day, we drew a circle, and in the center of the circle, we had something called a central angle. And I actually would put this in your notes, that a central angle has an angle of 50. The arc, the corresponding arc that goes with that, is also 50. Okay. Now, that was what we known before. What we have new is called an inscribed angle. You notice the inscribed angle goes all the way inside the circle, hits the circle, and then bounces back out. The intercepted arc is the part of the arc that is in that angle. So this red part right here. Okay, so right now in your notes, you have this, and let me just turn to the next page to see what we have. Yeah, this is what I thought. So this is really what we want in our notes here. It would be this part right here, guys. And then if I read the paragraph over here, it's the measure of the inscribed angle is 1/2 the measure of the intercepted arc. So let me give you an example of that. Let's say that you have an inscribed angle that has an angle measure of 20. The inscribed arc is 40 because you double the degree. If I would have said central angle and this would have said 20, this would have been 20 because it is a central angle, not an inscribed angle. Now there's 3 different versions of an inscribed angle, and here they are. And I would quickly draw these in your notes underneath this one here because it all means the same thing. So I would just draw these 3 just so you know that there's 3 different types of inscribed angles. Okay, do not put this in your notes. Right away when I look at the problem, without even looking at what they want as an answer, I see this 50 degrees and I know that this arc goes with this 50-degree angle. So I know this is 100 right off the get-go. That's what I'm looking for, guys. Now on the flip side of things, I also see this 48 as an arc. So I know the inscribed angle is half of that, or 24. Now that's before I even looked at the problem. Let's see what they want for angles. They got angle T. Angle T is that 24 degrees that we just found. And then they got the measure of our QR. Oh no, we didn't find that. Okay, it's right over here. Let me put an X right there. Let me highlight that in red for you. Q to R is right here, guys. Now, one thing that's unique is that all the way across, from T all the way to R, we know that's a half circle. That's 180 degrees. And this part over here is 100 degrees. That leaves 80 degrees for X there. So that would be 80. Okay. It's almost easier for me to draw this one from scratch just to show you what's going on. If 2 inscribed angles of a circle intercept the same arc, then their angles are congruent. So let me show you what I mean with the drawing. If you have a circle, let me draw a dot here and here. And let me highlight that arc for you guys. Okay. So if I make an inscribed angle covering from here to here, you guys know that if, let's say this is 20, this is 40, right? Because you just double it. Okay. Now, if I draw another inscribed angle using the same 2 dots here and here, let me make another angle. There. Bring it forward. If this is 20, this is still 40. Now, a question on the test would probably be like, they probably would put an X where that 20 was. That's my kids in the pencil sharpener. All right, so you know this is 40. They'd have an X right here. So now you can say that this would have been 20 right here. Okay. All right, so in other words, do put this one here in your notes, guys. And now that you know how to use it. Okay, this is another one that does not have to go into your notes. Just see if you understand what's going on here. I see 31 degrees as an inscribed angle. The intercepted arc is right here. I see one other inscribed angle that goes from here to here. And let me highlight that for you here. It would be the red one, and there it is right there. So this angle is 31 degrees as well, guys, because it has the same arc. Now the arc would actually be 62 because you double 31, right? And then going back to this inscribed angle in here, you're back to 31. Right, so name two pairs of congruent angles in the figure. There's actually lots of options here. So let's just say we concentrate on this arc over here. We know this angle is the same as this one, so angle J and angle M would be the same. We could turn this problem around and go from the opposite side. Now let's go from this arc. The two angles that I see that make up this arc are angle K and angle L. So that would be another pair of angles that would be the same. All right. So what they have here is an arc of 90, which means the inscribed angle is half of that, or it would be 45. Looks like the arc, you're looking for the arc. If this is 38, double 38, about 76. Another unique problem. So from Z to M, guys, is 72. Or I'm sorry, the inscribed angle is 72. The outside would be double that, right? But you know the red goes the same spot. So angle X would be 72 degrees. Okay. Inscribed polygon is inside a circle. An inscribed quadrilateral is in the inside. All right. Oh, this is one that's unique here. It has everything to do with this 90 degrees. So when you draw a circle and you have a diameter, you know that the outside part is 180, right? Well, if you have an inscribed angle, actually I wish I'd be here to show you this a little better because it's pretty cool. All right, so you know that from here to here is 180, and that this angle is half of that. This is also 180 from here to here. So here's the angle that goes with it, and that would be half of 180 or 90. Now, one really cool thing is if you make another one, let's say we start here and bring out, here's another 90 degree. Boy, my drawings are kind of crazy. There we go, cut it in half. All right, so this is the diameter of the circle. This is 90. Here's another one. Here's 90. Here's another one. No matter what, it is always 90 because that's your diameter, guys. Okay, so this guy here, please put into your notes. And this, I would actually draw in a 90-degree angle right there. Okay, we'll skip this one here. And let's see here. A quadrilateral can be inscribed in a circle if any of its opposite angles are supplementary. So opposite angles equal 180 degrees. So if you add up angle E and angle G, you would get 180. And then if you go to the flip side, angle D plus angle F would equal 180. So I would put the picture in your notes and this extra part that I have on the bottom here, guys. All right, and then just to test it out here, you know that 80 plus x equals 180. So in other words, x equals 100. You know 75 plus y equals 180. So y equals, oh, I messed up. I put 180. I see it now. It'd be 100, right? There we go. Because 100 plus 80 gives you 180. So 75 plus 105. So y would equal 105. All right, the next one. 2a equals 2a. We're not going to get anywhere with that. No. 2a plus 2a equals 180. There you go. 4a equals 180. Or a equals 45. Perfect. And then as a secondary one, you'd go 4b plus 2b. Put up there, 4b plus 2b equals 180. 6b equals 180. Or b equals, that would be 30. Perfect. All right, guys, and that is, that's it right there. Okay, these look like they're straight from your homework, guys. This one, yeah, this looks straight from your homework. So for number 5, you add up this plus this gives you 180. And then you set your next one, y plus 68 equals 180. Next one over here, a little bit harder. This plus this equals 180, and 8x plus 10x equals 180. All right, it's all pretty consistent. All right, guys, good luck. And we will see you on Monday. Have a fantastic weekend. Hey, Rosie, come here and say goodbye.
Goodbye.